On June 9, 2026, the National Weather Service of the United States issued extreme heat warnings simultaneously for more than 20 major cities: Texas, Missouri, Kansas, Iowa, Arkansas, Tennessee. The heat index in some areas of the southern plains approached 110 degrees Fahrenheit, which is 43 degrees Celsius, and this is only the beginning. 4 days later, on June 14th, the heat is expected to arrive in the Pacific Northwest. Portland, Oregon, a city where the normal June temperature hovers around 22 degrees, is bracing for 100 degrees Fahrenheit. That is over 37 degrees Celsius. The National Weather Service in Portland has issued an extreme heat watch for the entire metropolitan area, including the Willamette Valley and the Columbia River corridor. The current record for June 14th at the Portland Airport Station is 89 degrees Fahrenheit, set in 1988. The forecast exceeds it by approximately 10 degrees. But it is not about a single city, and it is not about a single weekend. Meteorologist Daniel Swain, a lead analyst at Weather West and one of the most cited climate scientists on the West Coast, published a forecast on June 4th. His wording is restrained, but to those who read weather maps every day, it speaks volumes. A powerful ridge of high pressure is forming over the northeastern Pacific Ocean. Its influence extends for 1,500 miles. Temperature anomalies in the mid-levels of the atmosphere are, and this is a direct quote from the model analysis, in a similar range to 2021. 2021, the year of the heat dome over the Pacific Northwest. The year when Lytton in British Columbia recorded 49.6 degrees. The year when Seattle saw 108 degrees Fahrenheit. The year when the estimated death toll exceeded 1,400 people. Swain notes a distinction. In 2026, we do not yet see an upper-level ridge of the same extreme amplitude that made the 2021 heat dome a 4.5 standard deviation anomaly, an event that statistically should not happen more than once every 10,000 years. But he adds that updated June model ensembles indicate the potential for even more extreme outcomes than in previous forecast cycles. The models are getting hotter with each recalculation. Meanwhile, several thousand kilometers to the east, on the Central Plains, the heat is already here. It is not approaching, it is stationary. A high-pressure system is trapping hot air from Texas to Nebraska. The humidity created by millions of acres of corn and soybeans makes the real feel 20 degrees higher than what the dry thermometer shows. And this is only the territory of one country. To understand what is really happening, one needs to take a few steps back and look at the map more broadly. Because what is currently unfolding in North America is not an isolated episode. It is a fragment of a much larger picture, and its contours became visible back in March. March 2026 rewrote ideas about what is possible at this time of year in the United States. And what happened then set the trajectory for everything we are witnessing now. On March 19th in Tempe, Arizona, workers were installing air conditioners, wiping sweat from their brows. On March 23rd, 4 stations in Arizona and California simultaneously recorded 112 degrees Fahrenheit, which is 44.4 degrees Celsius. This broke the record for the hottest March day in the history of the continental United States. It broke it by a margin of 4 degrees Fahrenheit. In March. Not in July, not in August, in March. The heat dome that formed over the Southwest turned out to be one of the most spatially extensive in documented history. According to weather historian Chris Burt, author of a reference book on extreme weather, the physical area of this event likely exceeded both the 2012 heat wave in the upper Midwest and the 2021 heat dome in the Pacific Northwest. The only comparable phenomenon is the series of Dust Bowl heat waves in 1936, but that was a sequence of episodes over 2 summer months, not a single continuous event in the calendar spring. 14 states recorded March records. The record for the entire United States as a whole was broken too. The World Weather Attribution group conducted a rapid analysis within a few days. Their conclusion was that an event of this scale would be virtually impossible without anthropogenic climate change. Climate change added between 2.6 and 4 degrees Celsius to the observed temperatures. Climate Central assigned a level 5 climate shift index to the event, the maximum, meaning that the likelihood of such an event increased at least 5-fold. Climate scientist Andrew Weaver from the University of Victoria put it briefly: "This is what climate change looks like in real time. Extremes are going beyond the boundaries we once thought impossible." But the March dome did something more than just rewrite temperature tables. It destroyed the already meager snowpack in the west of the country, partly through direct melting and partly through sublimation. By early April, about 55% of the continental United States was in a state of moderate to extreme drought. The same pattern was observed in 2012. The March heat transitioned into a summer drought that devastated agriculture across the country. And in 2012, just like now, this was preceded by 2 years of La Niña conditions, meaning the baseline background was identical. Only now, the planet's baseline temperature is higher, the atmosphere is warmer, the ocean is warmer, and what was an extreme in 2012 becomes a launching pad in 2026. A launching pad for a summer that has not even formally begun yet. And the signals are coming not only from North America. While North America was experiencing the March heat dome and preparing for the June heat, Europe was already going through its own cycle, and its chronology raises questions that do not yet have a definitive answer. On May 22, 2026, the first wave of anomalous heat arrived on the continent. Portugal, Spain, France, the United Kingdom, Germany, Ireland. On May 25th, the weather station at Kew Gardens, London, registered 34.8 degrees Celsius, an absolute spring temperature record for the United Kingdom, exceeding the previous maximum set in 1922 by 2 full degrees. The next day, the same station recorded 35.1. The record lasted less than 24 hours. In Moura, about 100 kilometers east of Lisbon, thermometers showed 40.3 degrees. In May. Climate Central estimated that this wave was 3 to 5 times more likely precisely because of anthropogenic climate impact. But to understand the weight of these numbers, one must remember what preceded them, because 2026 did not appear in a vacuum. It builds on a foundation that has been laid year after year. The summer of 2025 became one of the deadliest in modern history for Europe. The first wave hit as early as mid-June, earlier than the usual seasonal heat peak, which occurs in late July and August. National temperature records for June were broken simultaneously in Portugal and Spain when the thermometer crossed the 46-degree mark. Moura, Portugal, recorded 46.6. El Granado, Huelva province, Andalusia, recorded 45.8. Nighttime temperatures in Mediterranean cities and in the south of the Iberian Peninsula did not drop to a level where the human body could recover. The Copernicus service recorded that on June 30th, the average daily temperature across the Western European domain reached 24.9 degrees, a new June absolute maximum. This value, usually characteristic of the peak of the season between mid-July and mid-August, was reached a month early. By the end of the summer of 2025, the estimated death toll from the heat across Europe was around 16,500 people. Researchers from Imperial College London and the London School of Hygiene and Tropical Medicine studied data for 12 European cities for the period from June 23rd to July 2nd and established that about 2,300 deaths over 10 days in these cities were heat-related. Of these, 1,500 were directly linked to climate change, which increased the intensity of the waves by up to 4 degrees. And now, in 2026, the wave came even earlier, May instead of June. And it arrived in a context where baseline temperatures are already higher, the snowpack is already thinner, and the soil is already drier. The coincidence of calendar dates between the onset of heat in 2025 and 2026, a 6-day difference, proves nothing by itself. But it raises a question that climatologists are asking more and more frequently. Is the window of extreme heat in Europe shifting structurally rather than accidentally? The shift of the extreme heat window is a superficial symptom. Underneath it, a mechanism is at work, the scale of which becomes visible only if one descends several thousand meters below the ocean surface. In March 2026, oceanographic sensors in the equatorial Pacific Ocean recorded the formation of a so-called Kelvin wave, a massive pulse of warm water moving eastward toward the South American coast. Kelvin waves are a normal part of ocean dynamics. They occur regularly. But this one was different. The volume of heat accumulated in it turned out to be, according to preliminary estimates from several modeling centers, one of the largest in the entire history of instrumental observations. And it was this wave that triggered a chain of forecasts that by early June brought the climate community into a state that one of the former lead scientists at NOAA, meteorologist Ryan Maue, called Code Red for the Earth's climate system. We are talking about an emerging El Niño, not just an El Niño, a potential Super El Niño. The chronology of the escalating forecast looks like this. In March, the Climate Prediction Center of NOAA announced an El Niño watch and estimated the probability of a strong event forming by October to December at 1/3. By May, the probability of an El Niño appearing between May and July rose to 82%. CNN reported, citing an updated NOAA forecast, that the probability of the peak intensity being strong or very strong is 2 to 3. The European Centre for Medium-Range Weather Forecasts, ECMWF, went further. By June, its ensemble models showed that the ocean surface temperature in the Niño 3.4 region could exceed the average norm by 3 degrees Celsius by November. 3 degrees. This is territory that the instrumental record has entered only a few times, in 1983, 97, and 2015. The Australian Bureau of Meteorology published its own model of the relative Niño 3.4 index, which indicates the potential to exceed the peak intensity of all three previous Super El Niños. Analysts at Severe Weather Europe describe the situation as a turning point for the summer, and potentially for the rest of the year. What makes El Niño significant for heat waves is not the direct heating of specific regions. It is the reorganization of global atmospheric circulation. Jet streams shift. Patterns of blocking anticyclones change their geography. Zones accustomed to a moderate summer find themselves under stationary high-pressure domes that do not move for weeks. And the stronger the El Niño, the deeper the restructuring. But here is what makes the current situation different from all previous cycles. El Niño is not forming against the background of a normal climate. It is forming in an atmosphere that is already heated. The World Meteorological Organization published a forecast at the end of May, stating that the probability of the average global temperature between 2026 and 2030 exceeding the pre-industrial level by 1.5 degrees Celsius is 75%. Not a peak, the average for the 5-year period. El Niño adds heat on top of heat, and this superposition is already beginning to manifest. The superposition of heat anomalies, oceanic, atmospheric, and climatic, creates conditions in which the question ceases to be meteorological. It becomes physiological. And this is exactly where the boundary lies that most weather forecasts do not show. There is an indicator that the general audience learned about relatively recently, although it has been used in climate physiology for decades: the wet bulb temperature. This is not what a regular thermometer outside the window shows. It is a combined metric that takes into account both air temperature and its humidity, and it determines survival, not comfort. The principle is simple. The human body cools itself through sweating. Sweat evaporates from the skin surface and removes heat. But when the air is saturated with moisture, evaporation slows down. At a certain combination of temperature and humidity, it stops completely. The body stops shedding internal heat. The core temperature begins to rise. And if this process is not stopped, through air conditioning, through immersion in cold water, through any external heat removal, it ends in hyperthermia and death. For a long time, a threshold of 35 degrees Celsius wet bulb temperature was used in climatology, a theoretical limit beyond which a healthy person at rest, in the shade, with full access to water, is unable to maintain a safe body temperature for longer than 6 hours. This threshold was introduced in 2010 and has since been cited in dozens of studies as the boundary of adaptability for the species. But in April 2026, a group of researchers published a paper that calls this threshold into question. They reviewed 6 of the largest heat waves between 2003 and 2024, Mecca, Bangkok, Phoenix, Mount Isa, Larkana, Seville, and found that in all cases, mass casualties occurred at wet bulb values significantly below 35. Empirical data from the University of Pennsylvania confirmed that in laboratory conditions, not a single young, healthy subject reached the critical point at 35 degrees. The average threshold was 30.55 degrees, and for elderly people, according to a separate study in the journal Nature Communications, the upper limit of survival dropped to 21.9 degrees in dry conditions. 21.9. This is a temperature that looks like a pleasant summer day in a regular weather forecast. And this is where the data about the approaching heat takes on another dimension. When the National Weather Service issues a warning for Portland, forecasting overnight lows of 63 to 66 degrees Fahrenheit, and notes a 10 to 20% probability that the nighttime temperature will not drop below 70, it means that the bodies of people without access to air conditioning will not get a window to recover. Portland is a city where, by various estimates, a significant portion of the housing stock is still not equipped with cooling systems. The Pacific Northwest historically did not need them. The climate was mild, summers were tolerable. This definition is rapidly becoming obsolete. The vulnerability of the Pacific Northwest is a special case of a broader problem. And to see its scale, it is enough to look at what is happening on the planet right now simultaneously with the formation of the June heat over North America. The Indian subcontinent has just emerged from a heat wave that began back in April and lasted until July, earlier than the typical season, which usually occurs in May and June. On June 12th, 2025, a station in Sri Ganganagar, Rajasthan state, recorded 48 degrees Celsius. The number of confirmed deaths in India for April and May exceeded 450. And a year earlier, in the summer of 2024, Pakistan experienced a wave that claimed more than 568 lives in a single week in June, even though the heat index in Karachi reached 49 degrees. Power outages deprived people of fans and air conditioners at the height of peak temperatures. This is precisely the scenario that researchers describe as the threshold of non-survivability. Not because the air itself kills, but because the infrastructure cannot handle the load at the moment when biological survival depends on it. Europe, as already noted, entered the heat season of 2026 back in May. But behind the May records of the United Kingdom and the 40-degree heat of Portugal lies a context that makes the situation even more alarming. The summer of 2024, according to a study in the journal Nature Medicine, cost Europe more than 62,700 heat-related lives. 62,000 in a single season. The summer of 2025 added another 16,500, despite being shorter in the duration of extreme episodes. 2026 is just beginning. Its May wave has already recorded its first 11 deaths, and 1.5 months remain until the peak months, July and August. At the same time, only 20% of European households are equipped with air conditioners. According to the International Energy Agency, this is nearly 5 times less than in the United States. A continent experiencing one of the most sustained series of heat anomalies in its documented history remains structurally unprepared for these anomalies becoming the norm. Meanwhile, in the western United States, the March heat dome left behind another legacy that is spoken of less than temperature records: drought. The spring forecast from NOAA in March recorded above normal temperatures for practically the entire country: the West, the Plains, parts of the South, and the Midwest. The snowpack, critical for the water supply of western states, was destroyed by the March heat. And now, as the June high-pressure ridge begins to blanket the region, the parched soil is unable to perform its usual role as a thermal buffer. Dry land heats up faster. It radiates heat back into the atmosphere instead of spending energy on evaporating moisture. This is a positive feedback loop. Heat dries the soil, dry soil intensifies the heat. And into this loop enters a summer that has not even formally begun yet. The feedback loop between heat and drought is one mechanism. El Niño, reshaping global circulation, is another. The reduction of the real survival threshold relative to what was considered safe is a third. And when all three operate simultaneously on the same planet, in the same season, a configuration emerges that deserves special attention. Let us try to assemble the map. In the western United States, a high-pressure ridge is forming, whose parameters in the mid-levels of the atmosphere are comparable to the precursors of the 2021 heat dome. Its exact amplitude has not yet been determined. The models diverge, and that is why the National Weather Service is currently issuing observational watches rather than full alerts. But each new recalculation of the ensembles shifts the forecast toward more extreme values. The central and southern plains are already under an active heat wave with indices approaching dangerous thresholds. The East Coast, according to the forecast of the Climate Prediction Center, could receive its own episode of extreme heat between June 19th and 22nd. In Europe, the anomalous heat season began 6 days earlier than in 2025, and already in May broke records that had stood for more than a century. The continent enters the summer months after 2 consecutive years of mass excess mortality from heat. 62,000 in 2024, 16,500 in 2025, with a cooling infrastructure that covers only 1/5 of the housing stock. In the equatorial Pacific Ocean, a Kelvin wave of unprecedented energy capacity is moving toward the surface, and the consensus of modeling centers points to the formation of one of the strongest El Niños in instrumental history. Its full atmospheric effects will begin to manifest in a matter of weeks, and peak intensity is expected by November to January, but shifts in jet streams and blocking patterns are already being recorded. And all of this is happening in a climate system where the average global temperature over the past 12 months is the highest in recorded history. No agency at the moment is making a forecast that the summer of 2026 will become a record year for global heat mortality. No model gives an unambiguous answer to the question of whether the Pacific Ridge will reach an amplitude comparable to 2021. Data from recent weeks is still insufficient for a definitive interpretation. This is not an area of certainty. This is an area of observation. But the configuration of elements, the simultaneous presence of heat waves on 3 continents, the emerging Super El Niño, the revised thresholds of physiological resilience, the depleted snowpack, the parched soil, the infrastructural deficit, creates a totality in which each individual element is explainable, but their superposition upon one another generates a question that has no historical precedent on such a scale. The question is not whether it will be hot. The question is whether the systems, energy, medical, social, are ready for the level of heat that is becoming probable. The readiness of systems is a question that is tested not at the moment of discussion, but at the moment of impact. And what we know about previous tests does not inspire confidence. When the heat dome covered the Pacific Northwest in June 2021, Portland was not a city that had never heard of heat. It was a city that believed heat was not its story. Streetcar wires melted. Roads buckled. Emergency medical services operated in overload mode, and morgues overflowed within the first 2 days. Most of the dead were elderly people who were in apartments without air conditioning. They did not go outside. They did not make a mistake. They were simply in spaces that were designed for a different climate. After 2021, Portland took steps. New subsidized housing was required to be equipped with air conditioning. A program to distribute heat pumps and cooling devices to vulnerable residents was designed for 15,000 units over 5 years. These are real measures, but 5 years have not yet passed. And when the National Weather Service issues an extreme heat warning for the upcoming weekend, the question is not about what has changed since 2021, but whether what has changed is enough. A veteran meteorologist of the Pacific Northwest, Buhner, who has been forecasting the region's weather since the 70s, said in an interview last week that he is watching the models but is not sounding the alarm yet. He notes that the anomalies in the mid-levels of the atmosphere are comparable to 2021, but the exact ridge of extreme amplitude in the upper layers that turned the heat wave into a disaster is currently absent. This is a real difference. But he adds that the models continue to recalculate, and he is not one to raise a false alarm. When he says the situation deserves attention, it is a signal. The next 72 hours will show how the ridge behaves. whether it will shift further north toward Washington and British Columbia, limiting the heat impact on the coast, or whether it will intensify and expand, covering a wider territory. The models are updated every 6 hours. Each new run is a new set of probabilities. And beneath all these short-term questions lies a long-term one. The Kelvin wave continues its movement. El Niño continues to gain mass. The summer of 2026 is not the final point. It is perhaps only an acceleration before 2027, which, according to current forecasts, has every chance of becoming the warmest year in the history of instrumental measurements. Outside the window, it is June 10th. 10 days remain until the astronomical summer. Heat warnings are active on 2 continents. The ocean is accumulating energy that will last for months. Monitoring continues. Data is arriving. We are watching.